Key trends in maritime innovation, the role of digitalisation in the energy transition, and modelling and simulation in decarbonisation. These are just some of the topics you'll be hearing about today on the Seatrade Maritime Podcast. Hi, it's Marcus Hand, editor of Seatrade Maritime News here, and today you'll be hearing from Dr. Gu Hai at ABS. Dr. Gu Hai, welcome to the Seatrade Maritime Podcast.
Thank you.
Great to have you on to talk to our listeners. Could you briefly introduce yourself and your role at ABS?
Sure. I'm the Vice President of Technology in charge of Pacific Division. We have 4 technology centers in Pacific, in China, in Korea, and in Singapore. We are leading the team to work with clients and partners, such as ship owners, shipyards, research institutes, government agencies, to do a lot of R&D projects and try to develop products such as our rules, update new rules, new guidance notes, and software tools, new processes, etc., all including new services for ABS to provide to clients. So that's our main role here.
So a lot of things to do, and we'll delve into some of those as we go on in this episode. Now, just to sort of start off, what does ABS see as the key trends in terms of maritime innovation for the energy transition?
The energy transition is really driven by the regulation requirements and also the business pressures. And so the whole industry is trying to come out with technologically and technically and economically viable and optimum solutions, try to meet all the requirements from regulators and also the demand from the society. So that's one big background. And we see 3 trends. First of all, it's really the combination of decarbonisation and digitalisation driving the energy transition. And the digitalisation sometimes enable the decarbonisation. And that's one trend. The other one is the industry has realized that there's no single solution to fit all. So they're trying to develop the best solutions for each sector. And for example, like people are talking about electrification, but full electric is a good solution for maybe for smaller vessels like hovercrafts, but may not be the good solution for seagoing vessels. The whole system is increasingly complex. For example, we are not just talking about traditional IC internal combustion engines. We're talking about hybrid solutions. We're trying to use all kinds of different energy-saving devices. We are exploring new measures for operation to improve the efficiency of operation. Or we're also considering come out with a scheme such as green and digital shipping corridors, which will require different stakeholders to work together to come out with a solution which is much more complex than the traditional ones. So enabled to develop such kind of solutions, we need a new methodology to start from the very beginning of the solution and continue to use the new methodology to support throughout of the whole life cycle of the solution. So that's the third trend is the industry is trying to develop a new methodology to enable developing the new solutions for energy transition.
So you've got that complexity. You mentioned both the digital and the sort of decarbonisation technology there. So how can the digital side of that technology help accelerate shipping and maritime's energy transition?
That's a great question. Let's think about energy transition. It's really driven by the decarbonisation. Means we're trying to decarbonize the whole shipping. And it's well known that there are 3 types of measures can do that. First, we call is alternative fuel or energy. The second one is technological measures. For example, the energy-saving devices or better engines, more efficient engines, etc. And the third one will be operational measures. And the digitalization actually is in all the 3 different measures. Let's think about this first one, alternative fuel and energy. We are talking about using new type of fuels together with other technologies. For example, we're trying to use ammonia as fuel or even exploring hydrogen as a fuel. In many cases, we are talking about combine those new fuels with battery or other type of technologies. And in order to make those systems work well, you need a digital technology to support that. Sometimes even include the smart systems like AI-based solutions for energy or power management. That's for the first type of measures, alternative fuels or energies. The second one, think about technological measures. And digitalization is involved in many measures for that category. For example, we are talking about using wind assisted propulsion, or we are talking about using air lubrication systems. And you need to use that energy saving technologies at the right time in the right way, and to very efficiently and effectively work with other systems on board of ship. And again, you need a smart or sometimes digital technology to manage and control that complex system. And the last one is think about the operational measures. Where people are trying to optimize the voyage, depend on the weather, and try to reach the destination just in time. So you can optimize this voyage, the road, and the speed of the vessel so that I can save fuel, so decarbonize, and then arrive just in time. And for that, you need digital technology and sometimes AI.
So digital is actually integral across all parts of this energy transition for shipping there.
Exactly. It's cutting across all the different measures trying to do the energy transition.
That's really interesting. Just to drill down a bit, what role does modelling and simulation play in the decarbonisation of shipping?
Think about when we talk about the trend of energy transition is because the system is getting so complex, people need a new methodology to develop the different solutions. And modeling and simulation is the foundation of the new methodology. We are talking about transformation from a document-based methodology to a model-based methodology. What does that mean is, before we really implement a solution, we can build a digital replica of that solution, be it a real physical system, or it's just an idea or ecosystem like Green Shipping Corridor. We can build a digital replica of that system virtually in computer and simulate the operation of the solution virtually, considering all the different scenarios. And we can evaluate the performance of the system or even further optimize the whole solution. So this kind of method is called a model-based approach, and it's very critical when the system is getting more complex. So I can see that now is using modeling simulation is evolving from it's good to have to sometimes very necessary. I can give you an example is we talk about autonomous system, right? People are talking about we have autonomous cars, but now we are talking about autonomous vessels. Using autonomous navigation system as an example, we need to evaluate performance of autonomous navigation system thoroughly so that we understand that the system will do what we expected it to do in different scenarios. But it's very difficult to test the system in the physical world, considering all the different scenarios, right? Very risky and it's very costly. And so to develop and evaluate and verify and validate those autonomous navigation systems, one effective approach is you simulate the whole thing, the environment, and test the autonomous navigation system in a virtual environment, considering all the different scenarios, and evaluate the performance of the system. So in this case, modeling simulation is really necessary. And on top of that, using modeling simulation, we can really evaluate and optimize the solutions for energy transition. Another perspective is using modeling and simulation really can reduce the risk of using those new solutions. That's come from two perspectives. We can use autonomous navigation system again as an example, like before we really implement it, we test the system in the virtual environment so that we can consider many scenarios that we cannot do in the physical test. By doing that, we reduce the risk of implementing a complex system. And in another aspect is one important solution for energy transition is alternative fuels. But some of the alternative fuels, for example, ammonia, is toxic. people are concerned that by using this kind of toxic fuels, what if there's a dispersion or leakage? How will the crew or the operation, if we do the bunkering, for example, at the port, how will the environment react to that, right? We need an emergency response procedure for that. But how can we know the ERP or emergency response procedure is sufficient or is optimized? Actually, using simulation, modern simulation, we can simulate the different scenarios, like we can consider the dispersion of ammonia in different conditions, and we can simulate the reaction or response of the crew or the people, the ships, or the port operations to the dispersion. And we simulate ERP step by step, evaluate how effective it is, and further optimize that. On top of all this, like optimize the solutions or help reduce the risk of implementing new technologies for energy transition, modeling simulation can really play a very important role in talent development. Because when we do energy transition, actually the industry is trying to use the new technologies or new fuels. That's put a lot of challenges for different stakeholders, especially for crew. Think about the crew that they need to operate a system using, for example, ammonia as a fuel, right? How to handle those very toxic fuel is something new for the crew. And to train the crew to prepare for different conditions, it's not easy. So modeling simulation really can play a good role, important role in that. We can use modeling simulation develop, combined with the visualization technologies. For example, using the game engines, we can create an immersive training environment for the crews to train in different scenarios. And the whole immersive training environment is supported by simulation. That means the whole system, virtual system, will react to the actions of the crew and let the crew see how their reaction will lead to different consequences, which will be a perfect tool to train the crew to prepare for new technologies to be used for energy transition. And it's getting more important. So by doing that, we can have a systematic, quantitative risk assessment and use that to guide evaluation and optimization of the ERP for using energy solutions, such as ammonia as a fuel. By doing that, we can help to reduce the risk.
So there's a lot of things you can do there with risk modeling and the ability to try things out without having to do them in the real world.
Exactly.
Which wouldn't necessarily be possible with the example you just gave.
Yes.
Now, you did mention there examples you have for the energy transition that you with your clients. Could you tell our listeners a little bit about those?
Yes. We have done a lot of projects with different clients for different solutions. From a single subsystem of a ship, for example, fuel gas supply system, to the entire ship, or to as complex as a whole ecosystem like green shipping corridor. Many of the projects are confidential, so I can use one project as example, which is already public information. There's one project we work with a vendor, Vasila, a shipyard, it's Hudong Zhonghua Shipyard in China. It's to study a new concept, LNG carrier. The target is we want the LNG carrier to meet the regulation requirements for decarbonization and at the same time minimize the cost for the owners. So we are trying to get the optimum solution for future LNG carrier throughout of the entire life cycle to meet the regulation requirements and optimize the cost. So that's a problem statement. To do that, we need to explore a large design space. What does that mean is we need to consider the different power systems, either use the two-stroke engine or four-stroke engine. Should we just use the engine or itself or consider hybrid solutions? Or we want to evaluate using different energy saving devices or different fuels. So what we do is we work as a team, consider different hull form design, and consider different combination of power system and energy saving devices. And we build models for different combinations or different concepts and evaluate that in the virtual world to see which one is the best performer in different conditions. And with that, by doing that, the modeling simulations support the whole process, the concept design process.
It's really interesting to see how that actually works on a practical level. I think when we're talking about technology, one of the things that everyone seems to be talking about technology at the moment is AI. How can that be applied into what you're doing with the energy transition?
AI really can use in many different perspectives. I can see two types of AI. I mean, the ChatGPT type of generative AI is very hot topic. To use that type of generative AI to support energy transition is something new. The industry is still trying to explore how we can use that to support energy transition. But the more traditional type of AI is that industry has used quite broadly for energy transition. There are a few examples. One example is being used extensively is for water optimization, right? Yeah. Because it's a complex system, it's very difficult to model or simulate in using physics-based approach. But we have accumulated a lot of data so that we can use the data to train the AI to support water optimization. That's a big application of AI for that. But on top of that, the new power systems, we're combining the different fuels. We're combining engine, ICE, internal combustion engine, with batteries or fuel cells or other technologies together so that we can optimize the whole system. And in many cases, the smart energy or power management system to manage those systems is based on AI. Another application is AI is used to monitor the condition of the different power system and try to detect any anomalies and to predict maybe future failures to guide a condition-based maintenance or inspection programs. So that's just a few examples that how the AI can support energy transition.
So AI is something that's already really in use in the background.
Yes. Actually, there are more than that. I think about if we can see a broader energy transition, one aspect we haven't talked a lot is people trying to optimize the how to reduce the resistance, right? That's one area that the generative AI has been used to come out with the optimum how form. There are some researchers in UK, they use generative AI to do that. And it sounds very promising.
Oh, that's interesting. That's not something I would have thought of for generative AI. So it's an interesting development. Now, we've talked quite a range of things about how technology can be applied to the energy transition. Do you think that shipping and maritime is fully embracing the potential they've got here to use technology?
I would say from the mindset perspective, yes. The whole industry is very active, exploring all kinds of different technologies, including something we never thought about in the past. For example, the nuclear power, right? Or using AI. So really the whole industry is very active. But there are many challenges. So the mindset is one perspective, but really what kind of solution we really can use for different sectors. There's still many uncertainties and challenges to overcome. I think the whole industry is working to come out with solutions for that.
That's great to hear that the whole industry is working towards that. I think just to wrap this up, if we come back in a year's time and talk to you, what progress would you like to see made over the next 12 months?
There are really a lot. I would say two things I'm really interested. One thing is decarbonization is really a very ambitious goal for the shipping industry. There are so many uncertainties. And to come out really technically and economically viable or optimum solution is really difficult. I really hope the first thing is the industry can make progress to come out with a clearly defined roadmap for different sectors for decarbonization or for energy transition. That's one. The second one is really my interest. Our team is really working very hard to push it forward is I really hope we can make solid progress in terms of transformation from a document-based approach to a more model or simulation-based approach, which is important to enable developing best solutions considering the complexity. So that's the two wishes I have.
Okay, it would be great to come back to you in a year's time and see where we've got with those. Dr. Guhai, thank you so much for taking the time to talk to our listeners today.
Thank you very much. It's a pleasure.
Thank you for listening to the Seatrade Maritime Podcast, and we look forward to joining you on the next episode.